Hello, everyone. Hi, I'm Adelina, and today we're going to be talking about Form 3's journey to multi-cloud. I really appreciate the fact that you came to my session and that you're giving me almost an hour of your life, and I promise I'm going to do my best to not disappoint. I'm a technology evangelist at Form 3, and I'm actually a Gopher. I used to be a Java engineer, and then I swapped to Go, and you're going to see Gophers in a lot of my material. At Form 3, all of our code is also written in Go, but the technologies that I'm going to show you today are cloud agnostic and open source, and you can use them with a variety of programming languages. The multi-cloud project has involved a lot of engineering effort, and it's involved basically each one of our engineers. We have about 200 headcount at Form 3, and it's a huge honor for me to tell you some of the things that we've learned today. All right, so this is what we're going to cover. First, I'm going to tell you what multi-cloud is and why we decided to take this journey and migrate our services to multi-cloud. And then I'm going to tell you about all of the technologies that you see up here. So it's Kubernetes, Cilium, NATS, and CockroachDB. And the way that I envisioned this talk was to, because there's a lot to cover, right? Was to give you kind of like a snack bites, kind of where you can learn what they are. I'll tell you exactly how they fit into our architecture, but then you'll maybe want to talk about it more or research it some more. So I hope that it's going to be an inspiring session and that you'll enjoy it. All right, so let me begin by setting the scene and explaining our motivations. And the way that I have to do that is by talking about what we do and the financial payment system in general. So what you see here is Form 3 sits between the customer financial institutions, which are our customers, and the external payments infrastructure. You can imagine that when you transfer money from one bank to another, this is called an interbank transfer, the banks don't have direct integrations with each other because that would be like an absolute nightmare. Instead, they go through these external payments infrastructure, which maintain the contracts between banks. And these central infrastructures are well established and maintained by usually the government. And we make our customers' lives easier by taking care of all of the securing and scaling and all of the maintenance aspects of actually doing interbank transfers. But this also comes with some challenges, right? And these challenges kind of inform all of the decisions that we make when it comes to our technologies and our architecture. So first off, we process many transactions with virtually unlimited number of users, and we have all of our services have to be able to scale. We have customers that are tier 1 banks, and unfortunately, I can't tell you exact transaction numbers because maybe I'll tell you later. No, I won't. But you know, it's a lot of transactions. And secondly, we need to maintain reliability SLAs and recover from outages without dropping data or repeating data. If we drop data, then we disappear money into thin air. And if we duplicate data, then we create money in thin air, which is like maybe nicer than it disappearing, but it's still not ideal for, payments processing. And lastly, the external payment schemes, when I started at Form 3, I thought these wouldn't change very much, but actually they do. And the contracts change periodically, and you need to maintain all of the integrations with all of the payments, with all of the payment schemes that you maintain. And this can be very difficult if you have a team that's kind of like a smaller team that has to constantly manage and monitor. So this is one of the things that we take care of as well. Okay, so a nice diagram. So the cloud agnostic project has been rolling in phases since 2021. And actually what you see here is what we had before the cloud agnostic project, just so we can kind of like talk and set the scene, kind of like the technologies that we knew already and what we use. So the reason what you see here is one architecture. Well, first of all, this is a hybrid architecture. So we had our payment services that were hosted in AWS with SQS and SNS fan out for messaging, and we saved our data in Postgres and RDS. And the payment services, which are written in Go, you can see the Gophers, was hosted in EKS. And then we use Direct Connect to connect to our data centers, which were managed by our partners at Equinix. And the reason why we had to do these are two data centers, even though I've put one box there. Well, we had to do that because there's just some regulations when it comes to this FPS payment schemes that says you have to use leased lines and you can't do payment processing in the cloud. So, computer says no. So we actually extracted this project with the FPS payment services came later. And it was using CockroachDB as a distributed storage. Then it used NAT streaming and Cilium. And Cilium meshed the two data centers together. And it was running bare metal Kubernetes. And all of the technologies that are on this slide, you don't have to worry about because I'll explain what NATS is, Cockroach, and Cilium. And maybe a little bit we'll talk about Kubernetes as well. But the bank, as I already explained, the banking sector is regulated, and it is still one of the last to move to the cloud. And as we begin to process a large amounts of payments, there is a growing concern about being dependent on a single public cloud vendor. And we wanted to give our customers the choice and the peace of mind to run in any cloud. So this could be also to avoid vendor lock-in, because we are now able to process in any cloud that they want, but also it makes us tolerant to single public cloud outages. However, the primary motivation is to just give our customers more of a choice, and then we are also tolerant to outages. So from the very beginning, we wanted to offer an active multi-cloud architecture, treating the cloud as undifferentiated heavy lifting. And we love this idea that it doesn't really matter what cloud you're in, because you're able to rely on cloud agnostic technologies that can just take care of that by magic, right? And our existing hybrid architecture that I showed you gave us some experience to leverage, because we already had experience like running bare metal Kubernetes, and we had tried some things out. And in a way, what we wanted to do is take everything we've learned from running our payment services in the data centers and put it one level up, but bigger. And unfortunately, it's difficult. Spoiler alert. So from the very beginning, we identified some problems that, maybe this would be kind of an issue. And the concerns basically covered every part of our architecture, which is also what we are going to be talking about today. It's how we will do our discussion around these concerns and how we solve them, right? So you've got deployment, networking, event streaming, and your database solutions that all need to play well across the clouds. In particular, though, the multi-cloud connectivity was expected to be the most difficult. But, as I said before, we've got our cloud-native solutions that are cloud agnostic, which can help us. Of course, one option would also be to rewrite our entire platform on the specific cloud on the, for example, on GCP using the corresponding technologies. But that's kind of a pain because you have to like rewrite everything, then you have to manage it in this other cloud, and then you'd have to like repeat all of this all over again if you were to go to another cloud, for example, Azure. So instead, we wanted to use cloud agnostic technologies, and I think this decision kind of like speaks for itself. Just build one thing once and make it deployable everywhere. Okay, so let's start with deploying with Kubernetes, and then I can explain a little bit about how that works. Okay, so when it came to deployment, it was important for us that our teams and services shouldn't know what cloud I'm writing for or what cloud I'm deploying on. And engineers shouldn't be affected by this. So like developer productivity shouldn't be affected, and it shouldn't make their lives more difficult just because we're moving to multi-cloud. And also, one of the things that we rely on heavily at Form 3 is end-to-end testing. So we needed to provide environments where our engineers can do end-to-end testing of the entire platform. So these are kind of like some of the things that we considered. So through the magic of Kubernetes, we are able to do this. So it's one of the most widely used orchestration systems. So I'm not gonna like go ahead and like talk about it, but or introduce you to it. But still, I think it's interesting to talk about like why we chose it. So first off, it allows us to automate the deployment, scaling, and management even of like really complicated applications. So that's great. And it's cloud agnostic and allows us to deploy workload identically between the public and the private cloud where we were already running bare metal. And finally, it's extendable and we have operators and CRDs, which allow us to create custom behavior. So that's like a really cool thing. I won't tell you what we did with custom operators in this talk, but we can talk about it later. So we run our payments. So what you're supposed to get from this diagram is that we run our payment services over the three main cloud providers, which is AWS, Azure, and GCP. And we went with the managed Kubernetes offering, which are those little like icons that you see there. As opposed to running Kubernetes on VMs provided by the cloud vendors. And this has been working really well for our teams because we don't have to like maintain the expertise of actually running these Kubernetes clusters, and we can like rely on the good folks at like AWS or whatever to help us if something does go down. But it has been a little bit of a challenge when it comes to versioning, so that's something you should keep in mind. Like versions and dependencies won't be the same across the clouds, even with the magic of Kubernetes. And clients have private endpoints that they can connect to through the clouds, but the clouds, the payment services that run in each cloud don't communicate in the way that they can like swap work between each other. So if AWS goes down and you're trying to send me a payment to process, then you'll have to maintain a connection to another cloud, and then you can achieve your high availability, get your thing working by connecting to the other cloud. Yeah, and in general, we like to push as much responsibility to the cloud vendor as possible while avoiding vendor lock-in. So we definitely recommend that to anyone kind of like wanting to do this. And it'll be mostly because it allows our engineers time and like freedom to actually deliver what matters to us instead of maintaining clusters and other things that are not their expertise. Okay. And then I wanted to show you kind of like how our stacks and environments look like, which is like also quite a bit, kind of a really like cool way. So we have these stacks that span around the clouds, across the clouds, and they allow us to test the multi-cloud platform end to end, exactly like I said. Our teams maintain the ownership of these stacks. So for example, stack dev 2 could belong to FPS team, and the other stack dev one could belong to like the SEPA team. I don't know, I'm coming up with stuff, right? And we are also able to fully separate our stack into bespoke accounts. This is sometimes a client concern that they want their data separated from other tenants, or they want to have like specific billing on their own account. And for that, we have this concept of the jurisdiction. But the only thing that we should take away is that we need to maintain many multi-cloud stacks, not just one. And also the deployment has to flow from dev to test to production, because that's just one of the things that like has to happen in order. Okay, so we've deployed some stuff. And now this section is about connecting and securing the clusters that we've had deployed. And as I mentioned, we thought that this was going to be the most difficult part of the project. So we had some internal and client requirements. We needed to keep latency on our platform low. All of our platform is strongly consistent, so we can't like go ahead and introduce a whole bunch of latency in it, because that would just absolutely murder our transactions and our SLAs. We have client requirements around where data travels and where it's stored and everything. All of our vendors need to be audited. So that's like another thing that you need to keep in mind. And finally, the connections should be highly available and fault tolerant. As I said, like, we really don't want these kinds of outages to happen because of the connectivity. And also like automatic failover. If you have like one connection going down, you should be able to swap over to one that's working. So I said to you that I would mention what all of the cloud agnostic technologies are, and I really think these are really cool, but I'll just give you like a very quick introduction because we obviously don't have time for all of them. So I already mentioned that we use Cilium in our data centers to mesh our data centers, and Cilium is an open source technology that builds on eBPF, which is a Linux kernel technology. And this makes it very, very fast, and it integrates with the CNI. And the way it works is you deploy Cilium, and then the Cilium puts an agent alongside your nodes and your pods, and then it's able to do all of the functionality that you see on this diagram. Network policies and services and load balancing, and especially very detailed observability is one of the things that people really, really like about Cilium. And your workloads can be don't have to be containerized. They can also like run natively in the system. So that's just like a thing. So why did we choose Cilium for the multi-cloud? We were aware of it. We knew it was like really cool technology. But it integrates well with Kubernetes, and the network policies are actually, they're implemented at layers 3, 4, and 7. So you can secure your multi-cloud, and then actually your packets will be dropped at the lower level. We didn't want to like start writing like all sorts of application authorizations and all sorts of stuff across the clouds. And especially we had, as you can imagine, we have strict policies about ingress and egress in our clouds. It's open source and cloud agnostic. You're going to see this as a recurring theme in all of the technologies. It works in all of the clouds. And it provides detailed observability. I said like that's one of the things and what they have is this service called Hubble, which was is written specifically for Cilium, and it integrates well with Prometheus and Grafana, which are technologies that we already use. Okay, so I don't know if this slide is gonna like answer more questions than it like actually raises, but I'm gonna try and explain what we did. So we needed a very fast connectivity. Like I said, we can't increase the latency in our platform. And this system had to form like the backbone of everything we run, right? And we could connect the clouds via VPN, but that suffers from unpredictable latency and unpredictable bandwidth. So instead, and we also remember those like pesky audit requirements. So we actually decided to use the connections that we already have in place for our data centers. So the data centers already had like secure connections with all the redundancy and all the failover. So we use those connections to connect our multi-cloud together. But they would only hit on the edge router and not actually go all the way through the payment services. And the way we do that is we put some very high level routing on the edge router according to some CIDR ranges, which is what you see in on the lines written there. And according to these CIDR blocks, then the edge router knows like which cloud to send the traffic to. On the cloud side, we have transit gateways, and they then kind of like, okay, this is my packet, this is on this range, but let me forward this to this particular service that was like designed for it to go to. And the way we do that is that the cloud vendor CNIs actually allow you to have native routing. Which allocate like pod IPs so they can kind of take care of actually like connecting the Kubernetes, the actual services. And then, well, why do we have Cilium then? Well, we really like this thing about like security and doing the network policies. So we actually use Cilium for the security aspect of it and of course the observability. But it supports CNI chaining, so it allows us to work together with the vendor CNI, which actually takes care of the like service routing. And all of this together gives us some very fast connectivity. And I will say that we are cheating a little bit because the data centers and all of the actual like cloud locations are within 100 miles of each other. So they're very that's why it's very quick. But the connectivity, the latency is a couple of milliseconds in between. And if we were to go in, let's say, another country that's like very far away from where all of this lives, then we just have to replicate this whole system in the other location, if that makes sense. Okay. Yeah, and Cilium has the ability to run multi-cluster with cluster mesh, but we actually didn't use it because we had no need to actually mesh these clusters together. We have an event bus that we pass information with, which we're going to see in the next section with NATS Jetstream, another really cool technology. But cluster mesh gives you pod routing and load balancing, and as well as service discovery across the clouds. And the folks at Cilium, which is actually maintained by Isovalent, they've written a really cool deep dive, and they have a talk about cluster mesh if you're interested. So we might decide to use to mesh the clouds together in the future, but like right now we just don't have the need. Okay, so everything is connected, and now we need to start passing some information between the clouds. So if you remember, in our AWS solution, we actually had SNS and SQS, and we need to replace that with a proper solution, with a like multi-cloud solution. So obviously it needs to support multi-cloud. It needs to be highly scalable. It should be persistent because, we can't drop data and we also can't repeat it. And it should have Go client support because everyone writes Go. So those were kind of like the things that we were looking for. So now I'm going to introduce you to NATS Jetstream. You might not have heard of it, and it's really, really cool. So it's an open source, highly scalable messaging infrastructure. And it has these servers that are really, really easy to run. This is from their documentation. I didn't make this wonderful diagram. It has, so its servers start up, and then they provide endpoints that the clients can then connect to. And all of it is a really, really so all of the setup between the client and what you're consuming is done on the client side. So you can like spin up things really quickly and make changes on the fly without shutting down the servers. I think that's a really cool thing. And it has two qualities of service. So there's something called core NATs, which is fire and forget. So like at most once messaging without any persistence. And that is really, really fast. And then you have NATS Jetstream, which is what we use, which is exactly once messaging with durability, with delivery guarantees. So what you see here on this diagram is that messages are organized into subjects. That's what they're called in NATS. And then the stream defines how long to store a message and what how the particular persistence of that subject is. And then the consumers read from the stream, and they can either read in push or pull mode. So that's another really cool feature of NATS. If you're, let me try, I always get this wrong. In pull mode, you read in batches at the rate that's convenient to you. In push mode, NATS Jetstream pushes the messages and delivers them to you as quick as you can, while you still being alive, so you won't get like drowned with messages. You have to acknowledge that you've received them. Yeah, and it's really, really cool. It's open source and it's actually Go native, but have a look at it and read about it. So one of the things that I was always really why I asked a lot is, why didn't we go with Kafka? Like everyone goes with Kafka, right? The reason is that when Net's Jetstream is just so much more lightweight, and I'm going to show you exactly how it does clustering as well. But the reasons we chose it is because of these push and pull clients, and streams also support wildcards. So you can put like stars, and then you'll receive like multiple messages from different topics. So you can like put your not topics, they're called subjects. You can put together your subject as you need them. It's cloud agnostic and written in Go, as I said, and it provides horizontal scalability. So all of the NATS servers, they kind of like mesh together, and they gossip, and then you can like read from whatever server you have available for you. Okay, so this is what we did with it. We actually put together two clusters, and we call it the multi-cloud cluster and the FPS cluster. And inside the cluster, you have these nodes that you have servers as well as publishers and consumers in each of the clouds. And inside the cloud, inside the cluster, sorry, I didn't mean, inside the cluster, so across, for example, AWS, Azure, and GCP, the nodes talk together using the connectivity that we established before, and then they're able to like replicate the data across the clouds. Yeah, then we use leaf nodes. So what happens when you put two clusters together, in NATS terminology, you create a supercluster. And then the cluster's leaf nodes allow you to like pass traffic through without having to do all of the like gossip replication that I was mentioning before, which is one of the things that we didn't want to, we want to keep like data transfer in between the clouds, even though it's very fast, as low as possible. So that's why we went with this like supercluster terminology. But at the same time, information travels through really easily because of these leaf nodes. And what happens is like inside the cluster, everything is fully meshed. And then when they're together, all of the connections actually are highly available in between the clusters. Yeah, and you can like read, of course, you can read more about NATS Jetstream and how to use it. Okay, so the last thing we're going to talk about is database storage with CockroachDB, and I love Cockroach, even though I don't really love the name that much. So we needed to replace our Postgres database with something distributed, because we're very much adepts of like doing cloud agnostic as opposed to us like managing multiple databases and trying to like do whatever crazy idea. So it has to be scalable and strongly consistent, as that's like obviously something we care about. And ideally it should have SQL compatibility, because we didn't want to have like to move to multi-cloud and then also make a whole bunch of changes in the application and everybody like upskill into this new way of doing this stuff. So CockroachDB has the SQL compatibility, and it was like really great to have it. Okay, so the way it works is you have nodes, And ranges, data is divided into ranges, and ranges are replicated by Cockroach without you having to like worry about it. And you can read data, so like from any node. So even if node 4 doesn't have the data for you, it'll forward you on and it'll like fetch the data, right? And writes are only committed once you achieve quorum. And so it's actually like strongly consistent, like I said, and it has like ACID compliance, as you can see here. Once they achieve quorum, then your write is actually committed, and the reads are ranges have a leaseholder, and the leaseholder is like the leader of that particular range. So the leaseholder is the one that orchestrates all of the reads and writes on a particular range. And then of course when the ranges get fat, they get rebalanced and resplit. So I hope that makes sense. And yeah, it's open source and very fast. Yeah, I was going to mention under the hood, it actually uses like this massive key value store, and that's why it's like super quick. So we chose Cockroach because it has Postgres SQL compatibility, and it made it easier for us to switch our workloads. Then it's cloud agnostic. As I said, you can run it in Kubernetes, and it's like that's supported by it. All of the technologies we have, that's how we run them. And then you have the strong consistency, which was like huge for us, and it's really quite a unique offering for Cockroach, which is distributed. So what we did is, again, falling back on like the very quick connections that we have in between the clouds, we're able to split ranges across the cloud. So this is what I'm trying to convey with the different colors of the nodes. So we do use a replication factor of 3. And actually, our database setup is the reason why we went with 3 clouds and not 2. Because if we had two, for example, for a replication factor of 3, because they use Raft to achieve quorum, if we put 2 nodes in GCP and GCP goes down, then like we have a problem, right? So that's why we did 3, the 3 clouds that you see here. And the Postgres compatibility has been working really, really well for our engineers. Although there are some changes you should be mindful of when it comes to particularly how you're used to indexes performing, because the underlying structure is different. But you know, like these are just things that you'll have to consider if you move to Cockroach. Yeah. So in cap theorem terms, Cockroach is technically a CP system. And the folks at Cockroach Labs have done a really, really cool series of just blog posts and a couple of talks on exactly like what the cap theorem actually means for Cockroach. So definitely check that out. But because of the way that it's able to self-heal nodes and the way that we host it across the clouds, it brings up the availability, even though it's like technically a CP system. Okay, so this brings us to the end of this epic journey. And we can leave you with 3 rules of thumb if you do go to multi-cloud. And first of all, it's remember to test your services end to end. And this was one of the things that we were quite keen to get in place from the very beginning. Remember that especially in multi-cloud, errors and retries will happen more often than you're maybe used to, and this is where the end-to-end testing will make sure that you're able to handle these. And we use Toxi Proxy, which we can highly recommend for people to be able to test under different network conditions. And always, not always, but try to rely on the cloud vendor and on the experts that that run these cloud agnostic technologies, instead of try using your engineering time in doing something that isn't their expertise. Altogether, this is like a one view of everything that we've talked about today. So we actually brought, we have Nats Jetstream as our event bus. Then we have CockroachDB as our distributed SQL database. And then you've got your managed Kubernetes offering, actually the managed Kubernetes offering actually running the payment services. And everything is connected with hybrid network connections. So yeah, thank you so much for listening. You can check out our podcast. We have a podcast where we invite people. We've invited people from all of the technologies that I mentioned today. So we've had like Derek, who's a founder of Nats, and they tell you can learn more about the things that I was talking about. And definitely reach out to us on Twitter, where you can learn more about Go, because we post a lot about Go. Yeah, and then of course you can talk to me, you can ask questions now, but also talk to me later if you want to talk about like either this talk or Go in general. Thank you so much.
I have a question. Since you have experience with all three, which of the three clouds do you like best and why? Like maybe not your personal opinion or anything, but like what are your experiences like? What are the benefits and drawbacks of the various clouds?
That's an excellent question. Thank you for asking it. So we actually, obviously, our expertise, because I should have mentioned that the multi-cloud project migration is not complete, right? So our engineers are still working in getting this up fully in production, getting all of the payment services to actually operate multi-cloud. We do have most experience with AWS, but then actually GCP has been very similar to what we've experienced with in AWS, and Azure, the security in Azure functions a little bit differently. That's what we've found so far, but obviously they are able to run the kind of workloads that we need, and their managed offerings are great. So.
Thank you. You quickly mentioned that you're building your own Kubernetes operators. Can you maybe, like, very quickly tell us what problems you're solving with them?
Yeah, especially for Cockroach. So the way that we do, I should have mentioned, well, I didn't really have space in the talk, the way we connect everything. So in order to power this gossip protocols that, they need to transfer information to each other, usually the node, let's say like Cockroach, it'll be like cluster 0 dot svc dot local, you know how like that is called. And we use DNS chaining to be able to like forward on these requests to the correct node, and in the correct environment as well. So all of this needs to be decorated on the domain. So we've written our own custom operator in Kubernetes for Cockroach to help out with that. But I'm happy to. It wasn't my project, so I'm happy to like provide you with more information on that later. We actually wanted to do a talk about this in particular. I'm so excited. People want to hear more.
So one main thing about the different cloud providers is costs, right? And so sticking with one cloud provider, you can often get big discounts. So how have you found, or how do you expect your cost to change with using the multi-cloud platform?
So, as basically, it will be more expensive, exactly what you say, but compared to an outage and how much that would cost, it's like negligible, if that makes sense. And when the regulatory changes come through, then we'll have no choice, right? A lot of some of our clients like one cloud provider more than another. So they would say like we will try to like hit, for example, this particular one more, and then they're happy to support the costs. But like in multi-tenant, we usually use AWS as like the first call, as you say.
So is there like a percentage you expect it to increase?
I don't have the exact number, but I do expect it to be more expensive, that's for sure.
First of all, thanks. It was really interesting.
Oh, thank you.
I have a question. I'm curious about how you deal with provisioning and deploy all of your applications across these different infrastructures.
So we have the platform team, and the platform team is basically you get all of the infrastructure provisioned for you, and then you kind of like manage what you deploy on it. I don't know in particular what you're referring to when it comes to provisioning, but we do, for example, make some estimates and then we like pre-allocate resources and prepay them to make it more like efficient.
I guess that the question was like, what kind of tools do you use for provisioning, right? Like maybe using Terraform or some things like that. Like, you know, other like open source projects like Crossplane will help you in this multi-cloud space.
Yeah, definitely we use Terraform like heavily.
So it's Terraform
Yeah,
based,
yeah.
right?
And everything is and then everything is in the same way kind of like deployed and provisioned.
Perfect. Do you think that, are you using Terraform Cloud as well?
Yeah.
Yeah, good. Thank you.
This is not my area of expertise, but we can try and I'll figure out more detailed answers for you if you want.
And another on this line. I was wondering, now that you've done the multi-cloud bit and you're fully in there, and obviously you had the dream and the vision and you pushed it through, and that's great. Given the choice now, do you think you duplicate and tailor for each public cloud, or you definitely think that the multi-cloud was the way to go?
We definitely think the multi-cloud was the way to go, especially because rebuilding everything in the third cloud would have been even more time consuming than going cloud agnostic has been. But particularly, I told you like the migration of our services is not complete. So we're still, we still need to do the full performance testing and making sure exactly how to pass information in the best way. So for example, like we still don't know exactly what the payloads that are going to travel through NATs are going to be, and exactly how to synchronize our clouds. So yeah, there's still some work to do, but I was excited to be able to at least show you some of the concepts that we've discovered and how things work in our vision of the world.
It's epic. Well done.
Thank you.
First of all, thank you very much. With a lot of options in multi-cloud providers in terms of identities, how do you manage identities in this architecture? Are they delivered by your customers directly in form of any kind of system, or you choose a specific identity system upon a specific cloud? How do you solve the problem?
I don't fully know, to be honest, but what I've heard is that we have these private connections to our clients, and they get like a secure endpoint that they can call, and then I believe that everything is like then secured in the cloud together with Cilium, which has the network policies.
Okay, thanks.
Hi. Thank you for the press. So I do have a questions around Cilium, and I think your clients are in the banking sector. I guess
Yeah.
from the presentation. I think Cilium is an open source technology. Could you please explain how did you convince the banks to actually use Cilium for the security aspect?
Well, it is open source, right? But we get support from Isovalent, and we partner with them. So we have like the specific things that they promise to deliver. And I think usually, as long as we pass like audit and security, then then that's fine, right? The rest is just implementation detail, from what I understand. Cool. Thank you so much. We'll chat later. I'm going to be out there, and thanks for listening.